Okay, this is the state of Zoe. She still does not have her head. I'm trying to come up with a way to put brakes on her head to keep her head from wobbling when she's roaming about outside. I'm not exactly sure how I'm going to do that. She's got a Pololu servo driver that's pretty close to the top of her body, and that's what drives these servo wires, and they go through that hole and down into her body. And then right there is a 12-channel Pololu servo controller. Now if you notice here, I added this extra cable. I've got 12 channels in there, but her head only uses 3. So I've got extra channels, and believe it or not, a Pololu Maestro servo driver can be reconfigured to use those extra pins as digital output or digital input pins. So I built this cable and I tested it and I reconfigured it, and it really does have the capability of using those pins as digital output pins. Now when Zoe is outside moving about, she's not going to be carrying her video monitor with her. So as a backup to the voice commands, if I wanted to command Zoe to do something special, I kind of thought I could use these front panel buttons and maybe select a particular routine with one button and then press the other button to execute it. And that would be in addition to using the headphones with the boom mic in case that didn't work. So what I was planning on doing was using 4 of those pins from the servo controller to drive a 7-segment LED, which could simply display 0 through 9 and then a couple of weird combinations of the LEDs. And the main reason for that is I just happen to have a couple of those 7-segment LEDs laying around. Some of them have 2 characters, for instance. And I've got that one there is an old incandescent light that has 7 segments. And some of these are actually I think that's 4 character, but it's very, very small. So these green ones are the largest ones, so I was going to go with one of those. Plus, I have a few extras just in case. And that involves connecting in a BCD to 7-segment LED decoder driver, which basically creates the character combinations of LEDs to create the characters 0 through 9 and a couple other combinations. So with 4 bits in, you get a combination of 16 possible symbols on there. And so I have to wire that up. Now I have an old circuit from Radio Shack from many years ago, and that has the decoder driver on it. And this one also happens to have a counter, and there was a latch IC on there, but it wasn't really needed. And it's got some series dropping resistors and then it's wired to an old Radio Shack mock-up board. But the LED on there is a lot smaller than the green LEDs. So I know how to do this, and I made the cable for the driver board, and the cable comes down, and right now it's not terminated, it's not connected to anything. So I'm going to be working on that. Now, whenever you're working with parts bin free parts, you got to hit the data sheets. And this is an HDSP-5601, and that will tell you the pinouts, because the pinouts on these are not marked anywhere. And that's where I got that. And you can see on the picture on the left, the pins are numbered 1, 2, 3, 4, 5 across the bottom, and 6, 7, 8, 9, 10 across the top. There's two major kinds of 7-segment displays. There's common cathode and common anode. You got to make sure you have the right one. These are driven by basically a 7-4, 4-6, 4-7, 4-8, 4-9, and all the different variations of that. Low power Schottky, military grade, or standard TTL without any magic. But if you look at this active level, it says low, low, high. That's the output of these decoder chips. These are what takes your 4-bit binary coded decimal and decides which kind of characters to make. And if you see here, it'll make 0 through 9, and then a couple of weird characters for 10, 11, 12, 13, 14, and then a blank display for 15. So I like to verify things, make sure they're working before I proceed. Now this is a little test bed I set up. I got a display in there. I've got a series dropping resistor. This one is a 560 ohm resistor. And when I did the math to make the current flow of an acceptable level at 5 volts, it came out to be a 500 ohm resistor, which of course there is no such thing. And it said, go move it up to the next highest level, which is supposedly 510. I don't have any of those. This one is a green, blue, brown, which is 560 ohms. Now these displays are usually made to be multiplexed, and to make what that means is they run a whole bunch of displays off of one driver, and they pulse each display, so each LED is operating only a certain percentage of the time, and that keeps it from getting too hot and burning up too much current. But I'm not doing that, so I put the 560 ohm resistor in there, and I think that's going to be fine. And I've got the plus 5 volts connected to the anode of this display. This is a common anode. So to test the display, that's the decimal point. That's that segment. That's that segment. That's that segment. That segment. That segment. that segment, and the very center segment. So these all work. So I'm probably going to go with that resistor, that size resistor. You need 7 of them, 1 for each segment on the display. I'm not going to use the decimal points. I might use the decimal points for some other reason, but I don't really want to use up any I/O pins on my Arduino or on my fidget board or on my Pololu servo driver, so I'm probably just not going to use the decimal point. So since this is a parts bin project, I went digging through my parts bin to see if I had what I needed. I had a common anode display, so I needed a common anode decoder chip, and I got the 7446. I got one at Jameco. I think it was $1.50 or something like that. So we're gonna use that, and basically the way that works is, if you look on here, pins 1 and 2 are called B and C, and 6 and 7 are A and D, and that's your binary coded decimal, your 4 binary signals in A, B, C, and D. And then on this side of the chip, there's an A, B, C, D, E, F, G. Those are your 7 segments. So you put your binary in and you get your 7 segments out, and each one of those A, B, C, D, E, F, G, lowercase, goes to a segment through one of those dropping resistors. Okay, there is all 7 segments lit, and I'm using that decoder driver chip to make 0 through 9 and those weird characters. But if you wanted to, you could address these, each of the segments separately and make your own combinations. Like, for example, that could be an O. That could be a G or a Q. There's an E. There's a lowercase t. There's a lowercase c. There's an L. The only problem with that, I checked them all out, and there's some characters you cannot make. Like, you cannot make an M. You cannot make a Z. I mean, a Z would look like a maybe a backwards 2, or it might look like a forwards 2, and then you couldn't tell the difference. And an S might look like a 2. Okay, there's a 2. That could look like a Z or a backwards S or a backwards 5. So you couldn't make all the characters with that. You could maybe get real creative and light the decimal point if it's an alpha character, and have the decimal point off if it's a numeric character, and you could read it, but you still can't make W's or M's. Now I have the 7446 wired into the display through these resistors, and I have the 4 inputs wired into these switches, and it's switches 0, 1, 2, and 3, and the display is off. And if I toggle this first switch, okay, so I got a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then these other weird symbols. The first one looks like a lowercase c. Whoops. The other one looks like the lowercase c backwards. 7. 8, 9. Now I've already written code. I wrote a function called writeBCD, and if I call that function and pass it a number between 0 and 15, it will, those 4 pins, and it will write whatever number I pass it to the display. It writes the binary coded decimal signal on 4 wires, and that gets decoded into which segments do I light to make that digit. Now the only thing I have to do is wire the board and figure out how I'm going to mount the board on the robot. The next part of the project was board layout, board selection and layout. Now, I, for some reason, came up with picking this circuit board and went to town on it. Drilled out the corner holes for easy mounting, drilled some other holes for attaching the incoming cable with zip ties. Added a socket for my 7446. The display, I wanted to be mounted higher than the other components on the board because I wanted to protrude through a hole in a panel on the robot. So I mounted it on this, what used to be a full height chip socket. And this display is weird. It's got 5 pins on each side, and it's not spaced for a chip socket. So I cut the, I had some full height chip sockets, wire wrap sockets, and I cut one in half, and that's what I mounted on the board. Now for extra robustness, there is some hot melt glue holding that chip socket down. And on the other side of the board, I mounted a big power connector with three connections, so I can have a plus 12 ground and one extra connection for lighting the decimal point if I want. And I've done some wiring on it. Because all these pins are so long, I was able to use some wire wrap wire. It makes it really easy, even if you're not using them on wire wrap. Here I wrapped them around the resistor leads, And then since the resistor leads are round and not square like a real wire wrap pin, I just touch that with a little solder. But on all the square pins for the wire wrap sockets, I can just wrap them on there without any solder. So you can see my design originally started like that, and when I got them on the board, there wasn't enough room to put the resistors vertical like that, so I put them laying horizontal. But that's got so many close pins to wire, it's going to make even just seeing those pins to wire them difficult. But I'm going to give it a try. I think what I'm going to do is I'm going to wire up all the segments first and then test them to see if I screwed any of them up. Hey, does Zoe look different? This is the top of her body, and you'll notice there's the front panel switches and the left side door and the right side door. And hey, this is new. It's a new panel I put on there that I didn't cut exactly perfect, but I wanted it on there and I wanted it screwed down so that I could take a silver colored Sharpie from behind, which you can't see anymore because it's all closed up, and mark how much space I have on the back of this panel for adding the new display. And the new display board is here, and it has all of the components mounted. It's got the power connector, it's got the chip installed in the socket, the 7446 decoder driver, and I made this cable. I showed you this in an earlier clip, and it's got the connectors on there for connecting to the servo driver. And the back of the board does not look too bad. What I've done for all the signal wires is I used standard wire wrap wire, and it made things pretty clean. And I like using the stuff that's already stripped. It's 30 gauge wire. Now for the larger wires, for the 5 volts and ground, I use telephone wire. That red one is a +5, and that black one is a ground. And then I soldered those wires onto the chip socket pins for the decoder driver, and then I've coated those with hot melt glue and attached them to the circuit board. And that's for adding a little bit of robustness, because the robot's going to be bouncing around outside and something needs to keep those wires from being pulled off. Okay, I have the new BCD display mounted on Zoe's front. First thing I'd like to say is just ignore that big rectangular hole over the number 4. And let's see what it does when I push this button.
Black button pressed. New value is 5. Black button pressed. New value is 6. Black button pressed. New value is 7.
Okay, you get the idea. That's going to be used in a menuing system where I will press the black button until I get the number I want, and then I'll press that shiny blue button. and Zoe will execute some predetermined series of steps.